And we are recording. And folks, can you let me know if you can see my screen? Can someone let me know if y'all are seeing the slide up there?
Not yet.
I'm not. You're not seeing it yet. Okay. Let's try that again.
Yes.
Now you're seeing it. All right. So good. I think we are good to go. So folks, good morning. Happy Thursday. Glad you could join us for our latest Transformyx Tech Talk. I've got a little bit of a different one this time. The topic on this one is the introduction to network programmability. And if there are some of you on this call who are wondering what the heck this is all about, my goal is to, at least at some level, demystify all of that. At least that's my goal. So welcome today. One of the things I do ask is if you, while you're not raising questions, please put your questions in the chat window, or feel free to shout them out. But while you're not shouting out questions, if you wouldn't mind muting your phones. We are recording this session, and so when the session's over, I will email out the recording so you can pass along to others in your organization. Some of you are new names to me, so if you wouldn't mind letting us know which organization you're with, just put that in the chat window. That'd be great. And if you would like to be added to my customer email list so you'll get notifications of interesting factoids that I might find or about events such as Tech Talks, just drop me an email and I'll be glad to add you to my email list. Hopefully, I'm not spamming folks. So with some of that out of the way, let's go get started. Let's see. On the Transformyx team, do we have any Transformyx? Is Charles or Trey or Ryan on the call? Can't tell.
Matt, I'm on the call, but I'm mobile.
Gotcha. Okay. Okay, folks. So because I'm going between a few different screens, I'm going to be a little limited in my ability to look at the chat window for questions. So what I would suggest, if you don't mind, if you have a question, shout it out. That way I don't have to go back and forth looking at monitoring the chat window, because I've just got one monitor here. So let's go ahead and get started with our current Tech Talk. And oh, by the way, if there are topics that you would like us to present on for these Tech Talks, just let us know. We're interested in knowing what you want to hear about. I'd also like to know, after this is over, let us know what you think about this particular Tech Talk. So let's go forward. So this is my goal for today's Tech Talk. I want to address these questions. What is this stuff we're talking about? Why do you care? Or why is your organization care? Why now? Why wasn't this something we talked about 15 years ago? And lastly, how could you get started on this if you find it of value to you? So you be the judge at the end of all of this, whether I hit the target or not. The first order of business is I need to give a big shout out to Cisco. I'm using a lot of their slide deck for this presentation. And also the demos are based on a lot of the work that they've done, particularly in their DevOps and DevNet organization. Cisco, like all vendors, have moved toward this network programmability environment and are offering a lot of tools for you as the customer to learn about these environments, how you can make use of this stuff for your networks. Cisco, is my primary background is with Cisco. I was with Cisco for 15 years and I just retired in January. So they do an exceptional job, in my opinion, with making resources available to you. So I want to give a big shout out to them. But having said that, all the other vendors are doing very similar stuff. In particular, I want to give a shout out to Hank Preston. He fashions himself as a Cisco Devnet evangelist. And he does a great job of essentially evangelizing using things like network programmability for your organization. He's got some good training links, and I've got reference to those on these slides. So you heard the term network programmability, and this may be the first time you heard it, but you may have also heard a term network automation or network as code or net DevOps. At a high level, you can think of all of those as just aliases for the same thing. So hopefully that will at least clear up a little bit. They're all meaning essentially the same thing. So one way to start this off is just to give a basic definition of it, and we'll dive deeper into this, and hopefully it'll all start making sense. From a good book that was written by a couple of Cisco folks, it's a Cisco Press book. You'll see the reference down in the middle of the slide there. There is what I think is an interesting definition of network programmability. It's a set of tools to deploy, manage, and troubleshoot a network device. And sort of a follow-on to that, the second bullet is a programmability-enabled network is driven by intelligent software that can deal with a single node, a single device, or a group of nodes, or even to address the network as a single unified element. The idea that you're using software to drive the management of the organization. Now, my little addendum to this definition is this down at the bottom. This is as opposed to you, a human being, using the CLI or a GUI to interact with the network device. The idea with network programmability is you sort of remove the humans from the interface and have software interacting with the network devices, because we think there are lots of benefits to be had by doing that. So that's my definition of network programmability. Now let's talk about, why do you even care about this? Or why would your organization even care about this? Well, there are lots of good bullets. For one, this could allow your network team to scale. You can get more done in a shorter period of time, possibly, with network programmability. And as an add-on to that, you can save time. You can increase your network operations speed and agility, and that's becoming a big issue. We're finding more often that the other lines of business in an organization are often waiting for the IT organization, and in particular, the network organization, to keep up with their needs to drive the business. You could use network programmability to lower your operations costs, your OpEx. You could use network programmability to simplify repetitive tasks. If you're going to do a task 2 or 3 or 4 times, why don't you use network programmability and perhaps script that in some fashion and automate that so you don't have to keep reinventing the wheel? A very good feature of network programmability in my mind is reducing network management errors. You remove the human errors by removing the humans from the interface. Then once we say build a script to do a certain function across a wide part of our network, as long as we've tested and vetted that script that we're doing, well, guess what? We shouldn't have errors, and should be the functions that we want to accomplish can be repeatable and error-free. Network programmability is also something that can solve problems that perhaps the CLI or the GUI or something like SNMP can't solve. And one way I like to put that is when pointing and clicking just can't get it done. Now, the last bullet, and all you IT directors and CIOs out there, you might want to close your ears on this one. So, because for you network engineers, adding network programmability skill sets to your resume is likely going to increase your relevance and quite possibly your street value, because more and more organizations are looking for network engineers that have all the traditional skill sets, but they really like them to have some of those additional skill sets that we never thought of as being in the repertoire of a network engineer a few years ago. So I hope I addressed the why of why are we even looking at this stuff. As an example, particularly with that last bullet on the previous page, this is a page from Cisco's education site, certification site on the CCNA exam. Notice the little item down in the lower left that's circled in red. That's one of the topics that's covered in the exam. Automation and programmability. Now, think about that for a second. That's a new one. That is network programmability. So having that skill set is going to help you even at the CCNA level. Now let's talk about why now. Why weren't we talking about this stuff 15, 20 years ago? Well, there are some very good reasons for that. One of them is the fact that it's becoming more and more difficult to maintain networks for traditional tools. It's more difficult to simply keep up with the demands of the business. So we need to look for other tools that can make us more agile. Also, we're seeing a wider use and deployment and maturity in standardization of APIs, application programming interfaces. If there's one acronym you need to remember from this call, it's API, application programming interfaces. They've been around us for ages, but they are really coming to the forefront today. Some general examples of APIs that are used in networking environments are REST, RESTconf, Netcom, and gRPC, and I'll come on to talk about those. Another reason why we're talking about this stuff now is that we're seeing the standardization of data formats. Things like Yang models, XML, Json, YAML. In other words, we're coming to an agreement within the networking space that there should be some very standard ways that we identify what a device is and what the format of it is, like an interface on a router. You know, what are the things that identify? Is it an IP address, maybe a description, things like that? Well, instead of everybody rolling their own in terms of identifying and creating data formats, we've come up with some very standard models to doing this. And as we all know, as standardization increases, then you start to see uptake in the market in terms of vendors who bring solutions into the market. We see costs going down, all of those good things. We're also seeing a growth in the number of tools that make it easy to get involved with network programmability. Things like IDEs, SDKs, config management tools, source control tools, DevNet, sandboxes, and automated testing tools. And I'll come on to talk about those various things later. We're also seeing the advent over the last several years of some simple object-oriented programming languages. Three of the major ones are things like Python, Ruby, Perl, but there's others. And that's as opposed to languages that were much more complex. Way back in the day, to let you know how old I am, I started off as a COBOL programmer. Well, these programming languages are much more simple to adopt and to write and get moving on that. And they also tend to be interpreted languages as opposed to compiled languages. And lastly, there has been developing over the last several years a large online community that's willing to share code. So when you think of network programmability, don't think of the fact that, well, you're going to get into this area and you're going to have to do all of the programming to accomplish a task against your set of networking devices. No, quite the contrary. You will find that there are others who have invented that wheel before and are willing to share their code. So you quite often only have to write a very small subset of the code to accomplish an automation task. So these are a lot of the reasons why we're looking at this stuff now as opposed to many years ago. Any questions at this point? Okay, we will keep going. And I do have a question. I can't see who's on the call. Ryan Gordon, are you on the call? Ryan Gordon of Transformyx?
Yes.
Okay, great. Good. Excellent. Folks, just to let you know, Ryan Gordon is with our organization. He's one of our senior engineers, and He's going to come forward later in the call. I'll introduce him and talk about some things of interest related to network programmability. Let me give an example of some use cases, and these are real life use cases of using network programmability. Compliance checking. Are any of my 500 plus switches configured for Telnet? If so, let me know and disable. So one could write, for lack of a better term, a script or an automation task that does this automatically and maybe accomplishes this in a matter of about, I don't know, 3 or 4 minutes. A large car rental company deploying Meraki. They use network automation or network programmability to automate deployment of 2,000 plus sites in about 4 months. Another example might be regularly polling my wireless network and letting me know when an AP goes down by sending me maybe a message in WebEx or Slack or something like that. Another example might be the daily backup of a Cisco Viptela vManage database. If you're not familiar with Cisco Viptela is Cisco's enterprise, large enterprise solution for SD-WAN. And all of that data for all those devices that it manages are in the vManage database. And this would be a task that someone has actually written to back up that database on a daily basis. Now, I could go on for days with use cases, but look at that link down below. That's a place where you can go at the Cisco Devnet website to look at some actual real automation use cases. You know, the proof is in the pudding. One can talk about potential use cases, but when people go out and take the time to write code to accomplish a task, then you know that's a valid use case. So go take a look at some of those. Now, I referenced APIs earlier and how key they are, and they are absolutely the key to making this happen, okay? So let's talk about APIs. First off, what is an API? Hank Preston's got a nice definition. It's a way for 2 pieces of software to talk to each other. That makes perfect sense. If you look over in the upper right corner, that pink rectangle, what I show here, the bottom blue rectangle represents a networking device. Could be a switch or a router, firewall, it doesn't matter. And it's going to be running some software on it, probably natively, okay? That can speak the API language. And then you're going to have some software that you're running, maybe a Python script that you wrote. That's represented by the blue rectangle at the top. And so your software is going to want to accomplish some task with 1 or more networking device. It could be 1 device, it could be 1,000 devices, doesn't matter. And it's going to use the application programming interface to talk to your networking device, meaning that there's a specific way that you speak to each other to tell it to do something, such as change a configuration or to pull operational data out of that device. Okay? So APIs are key to all of this. I think it was, I had heard the urban myth, and it may be true, that Jeff Bezos, the founder of Amazon many years ago, had basically put down the mandate that APIs are absolutely mandatory for any software development that's done. And then if you don't develop an API with any software that you've done, that's grounds for getting fired. I don't know if it's absolutely true, but I understand that that's the culture that he started many years ago at Amazon. So a few more things about APIs. Software vendors are adopting an API-first approach to product development. Now, what does that mean? What that means is that when they develop new software, just about the first thing they do is develop an API. Matter of fact, you may find that, let's say, in terms of network management GUIs or network management software-defined controllers, for example, you may find that those GUIs or those software-defined controllers actually implement their functionality by doing API calls down into the network equipment, you know, what I would call southbound calls down to the equipment that they're managing. which means that before that GUI was written, the API was written. So you're seeing this more and more. But you're also seeing for older types of management systems where they weren't developed with an API first methodology, that they're playing catch up and they're all implementing more and more API functionality such that many can do everything that, say, a GUI can do inside the API architecture. So historically, people interacted with applications via CLIs or GUI. Well, now we have more and more need for software applications to talk to each other. Okay? Let me give you an example of that in the lower right-hand corner. So this is sort of an example of Yelp, how Yelp works. You know, that's the application that kind of gives you a feel for what are some good restaurants I can go to. So Yelp has all the data about the restaurants in terms of their quality, but it needs to query some other systems about, well, where are the restaurants that are close to the person who's making the query on their smartphone. So Yelp will use an API to go off to, say, Google Maps and say, hey, this fellow's located in this particular geo, in this particular GPS coordinates. What are the restaurants close to him? Google Maps will return that information via an API. And then Yelp would use that to sort of rank all the different applications. I mean, excuse me, the different restaurants and their quality, because it has that information. So that's an example of software applications using APIs to communicate with each other. Now, one of the facts about APIs is there are a set of rules on how two applications are going to communicate. They all have to agree. There has to be an agreed upon protocol, you know, just as humans are. You know, are we going to talk English to each other? Or are we going to talk French or whatever? So we have to have this agreed upon set of protocols. APIs have been around for years, but the maturity and uptake has grown tremendously over the last few years. Now, the leading APIs for the networking environment, for you networking engineers, which ones would you be using? These would be things that are based, APIs based on REST, RESTconf, Netconf, gRPC, and there are many others that are based on REST or RPC. RPC stands for Remote Procedure Call. APIs act in sort of a request response model. Some software makes a request of the device, let's say the switch of the router. It sends the API request to the device, and the device responds with some sort of response, you know, whether it was successful or not successful, whatever. Now, as we talk through this, and you being a network engineer, you may say, well, you know, there's been something in terms of managing the network, a software application for managing a network around for years, and it's called SNMP. And that is true. And it has been around for decades. However, it's got some issues. It's widely used and primarily used just for monitoring networks. It is somewhat rarely used for actually provisioning networks. And lots of reasons for that. Some folks haven't implemented writable MIBs in their devices. The performance of SNMP is pretty slow compared to what we need today. If you've ever looked at a MIB structure, it is complex. It is not fun to look at. And then you also have the security concerns. It wasn't until SNMP v3 that real good security was implemented, but lots of folks are not even using that. So SNMP is kind of being pushed to the side in terms of being a really good API for managing networks. So let's talk about the primary APIs for network programmability. And before I do that, though, are there any questions? Okay, well, let's go ahead and get started. So we have the REST-based APIs. They have been around the longest. And when I say REST-based, that means there are multiple APIs out there that are based on what's called the REST framework. And I refer to that as the big dog, meaning it's used a lot. But we also have something that's a relative newcomer called Netcom. And we'll talk about that. That's used a lot specifically in the network management arena in terms of managing networking devices. And then there is gRPC or Google RPC. That was developed by Google. It's being implemented more and more, but it's still kind of lags behind Netcom and REST-based APIs in terms of uptake in the world. So let's talk about REST-based APIs. REST stands for Representational State Transfer. So this is not a standard. What it is, for lack of a better term, sort of an architectural style or a framework of how one could write APIs. And there are what I would call attributes of a RESTful API. Things like statelessness, client server, cacheable, and there are a few other standard attributes that if your API is written in such a fashion, you would be considered a RESTful API. From a transport layer, like a TCP, UDP layer, it uses HTTP or HTTPS. So one tends to think of that, those protocols as just for browsers, but that is not true. REST APIs use HTTPS. CRUD capabilities, as in create, read, update, and delete, are done with REST-based APIs via what are called methods, or sometimes they're called requests. Things like get, post, put, delete, extract, etc. It's like get would be get information, post or put would be to add or update information, delete would be to delete information. Okay. These requests are made, and then you're going to get a response back from the device, and you may get it like a 200 OK, which is something we've all seen. We might see a 400 series response, which is not good, or a 500 series response, which is not good. Some examples of REST-based APIs are REST itself, but then the newcomer, the one that's in use much, much more for managing network devices, is REST-conf, okay? RFC 8040 describes it. It is specifically focused on using HTTPS, and it uses the Yang data model. And we'll talk more about that later. And that gets to that point I made earlier about we're standardizing on our data formats across vendor. And Yang is the primary model that we're standardizing on. So RESTconf uses Yang. It also uses JSON and XML data formats. XML stands for Extensible Markup Language. It's been around for decades. JSON stands for JavaScript object notation, or JavaScript object notation. Don't be alarmed. That doesn't mean you have to know Java to do this stuff. Okay? So one way to think about RESTconf, because it's relatively new, is that if REST and Netconf had a baby, it would be called RESTconf. Now, if we look in the lower right-hand corner in sort of the light brown area, this is what, when you're going off to make a REST API request, this addresses how you're going to format that request. In the blue, we're going to identify, well, which host or device we're going to go after. For example, this may be the DNS name or the IP address of a layer 3 router, for example, or a layer 2 switch. In the green, we're going to say, well, what is it that we want to get information on, or what is it that we want to configure? Is it an interface? Is it an OSPF instance or something like that? The resource on the device. And in the red behind the question mark are specific parameters. Like in this particular, because we're filtering down that request. In this particular case, this is a REST request going off to Google Maps, and we want to find information specific to the San Jose area. Here's an example of a WebEx REST API in the wild. WebEx is a big user of REST APIs. So there is the actual request. They're going out and they want to get information from WebEx about an individual person. So they're going to send that request. There it is in the green with the request itself, all the headers that go into it. We won't go into all those details now because we could be here for a very long time. Here's the response that you're getting back, and that's in the blue. And the response is a 200 OK that says, hey, this worked. Good job. Here's the information. And down in the lower half of the blue section is the actual information about this individual, Chris Lunsford. If you'll notice the way this thing is formatted, the beginning and the end of this data has little or squirrely brackets. If you didn't know, that's an indication that the data format used is JSON, as opposed to, say, XML, where it looks like greater than and less than symbols. And there's the different components of that response, the headers, the payload, all of that. Now, that's enough on REST because we're having to keep this very high level. Let's talk about Netcom. This is the API that was specifically developed for managing networking devices, as opposed to, say, servers or things like that. It's short for network configuration, defined in 2006 in RFC 4741, but then it was updated later in RFC 6241 about 2011. And the reason for that update is that update came to incorporate the use of the Yang data model in Netcom, because in 2006, there was no Yang data model. Now, unlike REST that uses HTTP or HTTPS, Netcom uses SSH. It has CRUD capabilities too, read, update, create, all of that, but it refers to them as operations. And some examples of these are a get operation, or a get config, or an edit config, or a delete config, etc. You kind of get the feel for how this is sort of very networkish. You have the idea of a manager, that's the client that makes the request, and then the server has the agent running on them that that's the response. So the server would be your networking device, like your switch or router or firewall. Now, it only supports sending back the data in XML format or receiving data in it. It does not understand the JSON data format. So it only speaks XML. Now, it too uses this standard model of this Yang model, such that we can all agree upon, how we describe different components in a device, such as a switch or router. So you've got those major APIs. You've got RESTConf and you've got NetConf. Those are the big dogs. You do have gRPC, which is not used much. So which one should you use? Well, the most important question is, what API does your network infrastructure support? If it only supports one, well, then you got to use that one. If it doesn't support NetConf, but it supports RESTConf, use RESTConf. But if it supports both, then what do I do? Well, one further question might be, is there a certain functionality that an API has that you need that the other one doesn't? That's not likely, but it's possible that one, like NetConf, can do something that is sort of a niche area that you want to accomplish, and REST or RESTConf can't do it. So that might drive you to NetConf. But if they can both do everything you need and your devices support both, then it's more of a personal preference. Having said that, we're saying that more folks, more traditional networking folks, like RESTConf better, because they're more used to the REST environment, the REST interface being HTTP, HTTPS based. They like the fact that it can also support JSON in addition to XML, because JSON is just a bit simpler and a little easier to read, and it's more familiar. So that's your decision path on which one should you use. So let's talk about this model-driven programmability stuff that I'm referring to. And I'm going to hit this at a very high level. So way back in 2002, the Internet Activities Board, the IAB, had a network management workshop. And I think the intent was that, hey, our network management tools for managing data networks just aren't keeping up. We're using a lot of old tools, one of them being SNMP, and they're just not cutting the mustard. We've got to do something. And part of that something is agreeing on a model of how we describe components in networking devices. It's been the Wild West. Every vendor describes and identifies devices or components in their devices in a different way. In other words, the database that sits inside of a switch or a router or a firewall, different vendors do it different ways, identifying things. And even within one vendor, they may change how they identify a component across different software versions. So something needed to be done, and RFC 3535, which is an overview of that network management workshop, this was sort of the catalyst for developing specifically things like Netcom, which is that API that's specifically focused on managing networking devices, and then also to move to a model-driven environment with Yang. So that's Yang primarily came out of this this workshop, if you will. Okay. Now, let's look at this a little deeper, kind of give it the big picture. The big green box on the right would represent a networking device. Down at the bottom, you have the various device features that we're all used to. Interfaces, maybe we're running BGP, maybe we want to implement some QS or some ACLs or whatever. Those are there and they're always going to be there, okay? Now, in the past, how we describe those and store those inside a networking device was all over the map, and everybody did their own. Well, with the Yang data model, we say, nope, we're going to agree on what we're going to do, how we're going to structure all of this. And we're going to break it up into two pieces or two areas of data. Configuration data, you'll have your sort of your configuration component of the Yang database on the device, and the operational data. That's the kind of stuff that you're not going to update, but you're going to pull out and get telemetry, such as how many bytes have we received in the last 5 minutes, et cetera, et cetera. So the Yang data model organizes it like that. Now, Yang is a standard, and there are standard Yang models on how to identify things, but it allows vendors to add functionality and create their own models to add to the standard Yang model. And all vendors do that, including Cisco. Now, how do we use the Yang data model in terms of network programmability? How does our application that wants to automate things talk to them? Where they're going to talk to these devices and pull out that Yang data or update that Yang data via those APIs. And that's going to either be Netcom or RESTconf or gRPC. That's how we communicate and make use of the Yang data models on those devices. Any questions about that? Okay. This is a little bit more detail on Yang. I'm not going to go into it as more of a reference line, but think of it this way. Think of Yang as a standard-based way of describing a database of the various configuration and operational components on a networking device. We can all agree on what an interface looks like. When we need to create an OSPF routing instance, what do we have to configure? What are those components, those attributes of that? To put it another way, to draw a comparison to something we know in everyday life. A model, a data model, is just something, a way that we agree upon on how to describe something. So in this case, I think we would all agree that a good way to describe a data model for a person might be identifying them by their gender and their height and their weight and their hair color and their eye color. These would be attributes of the model that identify an individual. So hopefully that helps there. This is just an example of part of a particular Yang data model. This is a particular a standards-based interface model. And notice that there are certain attributes: a name, a description, a type. Is it enabled or not enabled? Things like that. Now, when we want to work with that Yang data that's sitting in that networking device, we're going to make a request over to the device, and we're going to use one of those APIs in their associated transport protocol. So if it's Netconf, it'll be SSH. If it's RESTconf, it'll be HTTPS. So we're going to send that request off to that networking device, and we're going to format that data, that Yang data. If we are pushing data to that device, we're going to format in either XML or JSON. And then that receiving device is going to receive that XML and JSON and know how to push that down into its Yang database. And then on the other side, if we're pulling data out of that networking device, that data is sitting in a Yang format inside the networking device. That networking device, whether it's a switch or router, is going to format it in XML and JSON, put it in the packet, and send it back in a Netcom or say RESTconf response. So that's how we make use of that. This is just a reference slide. And what I'm depicting here is how 3 different data formatting languages to identify an interface. To the left is Json. You can always tell it because it's a little more readable, and it's always ends and begins and ends in squirrely brackets, squirrely braces. Upper right is XML. It has the begins and ends with the greater than and less than symbols. And then we have a YAML format. And I'll talk about YAML a little later. I'll just spend just a couple of minutes on it. That's another way to describe data. Okay. So Pat, earlier in this call, you talked about these tools that are that have come about that really help us get started and be successful with our network programmability tasks. So let's talk about this. First off, we've got some cool languages, programming languages that are much more simpler to put in play and learn. Python, Ruby, Perl, and some other ones. My recommendation is if you're going to get into network programmability, start with Python. That's probably got the largest backing in the net DevOps community. A lot of code out there that can be shared with you. So go with Python. You have source control tools. These are tools that allow you to work collaboratively with a team, with other folks. So if you're going to share code with other folks, wouldn't it be good that you all agree on the certain state of an application? That if I make a change and that we want to keep, that change gets incorporated into the code that you're going to eventually change or use. So we need to make sure that we have a single source of truth and a way to control that. And source control tools do that. The number one source control tool out there is Git. And that Git is a source control tool. It's software that you can actually download on your device. But one way you can share is you want to push that your changes up to a source control a place, a location that can store that you can collaborate with your friends, people on your team. GitHub is an example of one of those repositories. Another one is Apache Subversion. Another tool that's real handy is IDEs, interactive development environments. These are tools that make it a lot easier to work with, to create programs or scripts or whatever. They're structured such that, for example, they may know that you're writing a Python code, and they may be able to help you write that code in terms of, doing the right, putting colons where they need to be or spacing out things where they need to be. It just makes it a lot simpler. So IDEs are already good, always good. Config management tools, the idea that you could store off configurations, pull them into into an automation script and use them to go out and update any devices you want. Some good config management tools are Ansible, Puppet, Chef, and there's a few others. Now, if you're going to get started on this and work with this and test this, you need a network to target, to play with. A good one is Cisco Devnet. Their sandboxes are great. They're free. Cisco Viral's another one. Cisco CML, which stands for Cisco Modeling Labs, is good. GNS3. I personally am using EVE NG, which is Emulated Virtual Environment. NG, I guess that's next generation. Python libraries. Python libraries are one of those sets of tools that allow you not have to rewrite the code. Use code that can simplify the amount of code that you have to develop to automate something. Software development kits, we all know about those, and they basically are pieces of code that's done for you that minimizes what you'd have to do. Some other tools are tools like curl, Postman, interactive Python, pip, and the list goes on. But these are all lots of tools that make it easier for you to get into this space. Now, as I was prepping for this tech talk, some of the tools that I use are these listed below. I've got Python. I've got an IDE called VS Code or Virtual Studio Code from Microsoft. I'm using Git and GitHub. I'm using Cisco Devnet for their sandboxes and lots of other things. I'm using Ansible as a config management tool. My emulated network is based on EVE and G. I'm using a tool called Postman, curl, and pip. And guess what? All of these tools are free. I haven't had to pay a cent for them. And I'm not stealing them. It's all legal. So if APIs are so key to all this, Pat, how can I get started using it? How do we use these? If I got to write a program day one, man, that's a lot of legwork to do to get started in this area. Well, that is one possibility. You could go in, say, learn Python and write your own program. Okay? And I'll give a little example of that. But there are a couple of ways to get started easier. For example, you can go, all vendors have API documentation pages. They tell you which APIs they have available, what they do, and how you should structure them. But they also, in many instances, let you actually run the API from that page against a target device. And I'll show that. There's also a tool called Postman that you can download and run on your laptop like I've got. And Postman allows you to put in an API and run it for you without any code. So let's move forward and let me show you some of this stuff. So yeah, so here's Postman. If you want to get it, just go to that site. It's free. It's great. It used to be a Google Chrome plugin, but today's world, you want the application. Load it. It's a great tool. Is what the Postman interface looks like. This is sort of a reference slide, but as you can see in the top left, you tell it, and Postman is primarily a REST-based API tool. So here we're doing a GET, we're identifying the URI, what we want to go to. If there are any headers or authorization headers that we need, or any body of information that we need to include to make a successful request, we have places on the Postman screen to include that. We click the send button in the upper right-hand corner, the blue, and hopefully we'll get back a response code on the right-hand side in the 200 range that said it was good. And then we'll get a response body perhaps. By the way, this particular website is great. It's the Chuck Norris jokes database. So you can actually go off and send APIs and get a new Chuck Norris joke back. And you can tell it what kind of jokes you want. Do you want them geeky or what? So as an aside. Now, we're going to do a little demo with Meraki APIs. Now, if you're a Meraki customer, it's easy to get started with Meraki APIs. One of the things you have to do, though, is you have to enable API access. And the way you would do that is you go to your dashboard, go to Organization, Settings, Enable API Access, and click Enable Access to the dashboard. Then you would go to your profile and generate an API key. Because when you create, say, an API, let's say you write an application to talk to your Meraki devices via the Meraki API, you have to authenticate to those devices. And the way it's done in the Meraki world is by sending that key over. So you would copy this key into your request, send it across to the Meraki device, and it says, oh, okay, that's Pat. He can do stuff with my gear. A similar, this is used a lot in a lot of networking environments. WebEx does something similar. Here's the Meraki page. So for doing APIs, and I'm going to switch over here. Let's see. Bear with me just a second. Okay, here's the Meraki API page. And let's run one of these APIs. So I'll click over to here. This is on developer.cisco.com/Meraki/API. I'm going to on the left click on APIs. I'm going to go down. I'm logged in, and I've already got my API key. Let's see what kind of APIs we have for organizations. Okay, here's one. Get organizations. So I'm going to send a REST API request to Meraki, say, as my particular user, which organizations do I have access to? This is an example in the middle left, a middle lower of what the response might be. If I wanted to look at the configuration, oh, excuse me, not that. Let's see. Here are some of the headers that could be used here. There's the Meraki API key that what I would use to do this. And because it's not asking for any information other than Meraki key, I'm ready to run it. So I can run this right now. And boom, we got a 200 OK. It went off to the Meraki cloud and it came back with a series of organizations that I have access to. Okay, so that's good. Let's see, I want to dig down. I want to look at this organization with this ID. Okay. Let's see. And in the Meraki world, the way to uniquely identify individual components in a Meraki environment is via their ID, not their name. So let's go and let's look for networks. Get organization networks. Okay, I want to tell it for one of those particular organizations what networks are out there. So there's the structure of this API. I do have to provide a piece of information. It's the org ID. So let me paste that in there. Let's do a run on that. Oh, got a 200. Okay, good stuff. These are all the networks that I have access to. Okay, that's good stuff. Okay, now let's dive into this particular network. Let's grab its ID. Okay, copy that, and let's go get a list of all the devices in that particular network. So I go to the devices APIs. Let's see, get network devices. I think that's the one I want. Yeah, and it's asking for a piece of information, the network ID. So let me paste that in there. And I'm going to hit run. And boom, got a 200 OK. These are all the devices that it knows about. Now think about doing this programmatically. I could do this programmatically. Matter of fact, let's try something here. Let's go to this template thing right here. Let's do Python request. And it tells me here's what the Python code would look like for this request. Well, let's copy this puppy over here. Okay, and having done that, let me see if I can move around here. Let's get in trouble. Let's see if I can. Let's go. Let's see if I can. Let's see if I can go into Python. And I'm in the interactive Python, and I'm going to paste that program in. Let's see what happens, see if this will work. And sure enough, I ran a Python program, and this is a response back. Unfortunately, it doesn't format it very well. What I got back here, highlighted in blue, is all the devices in a network. So the point being is that an API documentation page like this is great because it tells you how to use the API, but it also gives you an example of lets you run the API. So let's get out of that. Let's see. Let's see. Let's go back to my slide deck. Now, let's do that same thing, but let's use this Postman tool. I'm going to go out and get those same things. So I'm going to go to the Postman tool. Let's see if I can get that Postman tool up and running. There we are. So here's Postman, and I've collected those three different APIs, the one that lists the organizations, the one that lists the networks, and the one that lists the devices in a network. I've created what's called a Postman collection. Here they are here. So let me go. This is my here, a second here. I'll get there, folks. There we go. So here's my workspace. I've got different collections of APIs. I've collected some Meraki APIs. There they are there. So basically it allows you to construct the API request. So I'm going to list my organizations. There's the GET request. I have saved all the needed information in what's called an environment. And that environment is, these are the things I needed, particularly the API key. And let's see if I can run this command in Postman. Yep. And sure enough, I ran that. I got all the organizations back. I can do the same thing for the networks. I'm going to list the networks in my organization, and I have saved the organization ID up in the environment variables. I can do the same thing here. And sure enough, there are my different networks. And then lastly, I can list the devices in my networks. And I have saved the network ID that I want to use on this REST API in my environment variables. I hit send. And sure enough, there is all the network devices. Now, here in Postman, I can do the same thing in terms of the code. I can click over on the right here, and it will tell me in different languages what the code would look like. So here's an example of in Python, and I could copy this over and run it in the command line, just as I had showed you earlier. Yeah. Now, that's any questions? Let's go back to the slide deck. Bear with me. Here's an example of using what's called the Ansible config management tool to go out and go after some devices. Let me show you an example of using that. So what I'm going to do, exit out of that. Okay. And I am going to see if I can grab some information. Bear with me a second and pull up the right information. I want to run an Ansible job against 4 of my iOS devices. I've got a small emulated network, and I want to go query, make some iOS commands against them. So that's what I'm doing right here. I'm using the EVNG tool to go out to get the iOS version of those devices, to do a show IP interface brief, then to show users on all of them. And it was successful. Now, this was 4 devices, could be 400 devices, it doesn't matter. And the actual network that I'm running this against is this network right here. I've got 4 CSR routers all running in a virtual environment on my laptop. Okay. So that's just an example of using a Python program using the Ansible configuration tool to actually go out and use network automation. So for purposes of time, let's go back here. These are reference slides for you. Now, the last little piece of information about, I mentioned this YAML stuff. So again, YAML is a configuration tool, and you can use it to basically automate doing a lot of different tasks for your networking devices. You could create something called an Ansible playbook that says, I want you to do this. Maybe configure a loopback 0 interface on all the devices. And then another task that says, I want you to go out and check and make sure all those loopbacks were there. The number of tasks that you can do are endless. Matter of fact, the way you architect it is you create what are called plays in a playbook. So a playbook, an Ansible playbook would have multiple plays, and then within each play, there could be multiple tasks. So this is just a reference line for you to talk about Ansible. We could spend an entire week on Ansible, if you will. Now, just so you know, many customers may want to benefit from the capabilities of network programmability, but they just don't have the staff to support it. So, did you know that Transformyx has some expertise in that regard, and your organization might be able to benefit from it? So, having said that, let me introduce you to someone on our team And that is Ryan Gordon. He's one of our senior network engineers, and he is a DevOps practitioner. Ryan has actually used this network programmability capabilities to help his customers with various solutions out there. So I'm going to let Ryan talk for a couple of minutes about some things that he's done to help our customers. Ryan, take it away.
Thank you, Pat. Hi, everybody. My name is Ryan. I am a very heavily use of network automation and network programmability for supporting DevOps. Some of the things I have used before, as Pat have on the slide here, I used it for onboarding new users and adding them to groups. So the way that use case was, a client, they wanted to when a user gets put into an HR system, they wanted to be able to say, all right, we're going to create this username and use network programmability. And they also use Ansible in this case as well to reach out to their server, configure the username, all right, based on the user profile or what department they're going to be in, automatically assign them to their groups using their automated system that they use on the front end, I believe was ServiceNow. So ServiceNow had an API call to an Ansible control node, and the Ansible control node used its configuration management tools to manage ICE and its APIs. And the same went for the second bullet point. People are all about security. And so one privileges that people don't want is give everybody God privileges all the time, especially like if you're a domain admin or a network admin, you have free write privileges for all your network equipment. So this particular company, they decided to, well, they're going to give everybody read-only access. And if you need elevated privileges, you'll go to the automated system, you'll give them your username, and then the system will do their network automation. They will look up that username, look to see what groups you're in and what groups you need to go to get write privileges. It will then add you to their own group that has read-write privileges for a certain period of time. Once that allotted time is over with, you go back to just having read-only access, which was something that they wanted to automate for a security standpoint to meet some type of objective, which also helps them from a standpoint of being more secure. Say, well, if a user gets hacked or compromised, they don't have to worry about, oh, shoot, we got to go and try to hurry up and deactivate the user account, because they don't have to do that anymore, because that user account don't have free access to begin with unless they are authenticated and go through the automated process, and which says to have read-write privilege only for a certain amount of time. So most of this slide stuff that we have up here talks about configuration. For people that's getting into network programmability, the first thing that you probably want to do is more so like network monitoring or pulling data. A use case that I can think of off the top of my head is for Meraki wireless solution. So you can set up your own server in Microsoft Azure or AWS Cloud, or you can use a private cloud solution where you set up a server and you have your Meraki dashboard, send a webhook to your specified endpoint, and you can collect data for uptime. Let's say if a AP goes down, you'll be notified that AP went down, but you don't want to just use it for that, you can just have regular Meraki alerts for that, so you can get more granular data when you use it for those types of situations. So, well, how long was this AP down? Especially if you have like a service contract with a provider that has like different solutions, you can say, well, you can monitor certain things. Say, well, my AP that we bought from you has been down like 85% of the time. Y'all sold it to me saying that, well, it'd be up to say 95% of the time, and you probably get something, well, based on these solutions and data, well, you could terminate your contract with this certain provider because they didn't meet your specifications, and you could get that information through network programmability without the hard work of having to set up a complicated system. And that's just one example of what people use it for today for analytics. You can also integrate it with analytics platforms like Power BI as well. For some people out there that might be Windows friendly experts. Other things that people use it for is like VPN configuration. So what they do, they set like a base template that what their network looks like, and then they could just say, "What we're gonna launch this template against all devices, and then the new devices coming in, we give them that name, that new template as well." So what this does, it takes away the ability from having two different engineers configure the same thing, but do it two different ways to make it a standardized way of doing things. Perfect example is that would be like you try to do an EIGRP configuration. You can do it the old way using the number system, or you can use the new way of using the name EIGRP. Both ways work, but if you have an issue, you have to troubleshoot. If one side used one method and the other side used the other method, you have a little harder time figuring out, all right, which way is right if they both did it two different ways. So you can also use network programmability to standardize on your configuration, and takes it off into a different point of view of using your network and infrastructure as code. So by doing it that way, you're also doing documentation. So when you do these templates, you're basically saying how the network should look, instead of saying, I want to use this command, show IP interface brief or IP interface gig 0. Instead of implicitly saying those things, you could say, I want the network to look like this. I want the network to have VLANs 5, 6, and 7, instead of saying VLAN 10, VLAN 20, VLAN 5, 6, and 7. That way, it's mostly in a documentation form, so that way it be documented in, because I don't like documentation. I don't know about the rest of y'all. Documentation is one of my weakest points. So to use network programmability and also covers documentation, that's like a win-win for me.
Very good.
One of the other things I used it for is probably the last thing I talk about. I could just talk about this stuff for ins on out for a Meraki deployment. So a client in our New Orleans area, they wanted to deploy Meraki switches, and they had a whole bunch of them. But they didn't want to just push out configuration, then all of a sudden everything didn't work. So what we did, and we used network automation to configure 3 ports on the Meraki switch using programmability for testing. And if those 3 ports came back and validated correctly, we then had the network programmability say, well, if these 3 ports perform with no problem, automatically push the rest of the configuration out to all of the other ports, which streamlined the event of configuration of the Meraki devices. So when you got Meraki GUI point click, and you got like 8 switches in a stack, and you got to configure all that in different closets on different floors, that can be very time consuming from a Meraki GUI standpoint. So you got to click on each interface and configure that one port one by one. And you can have that automated through a Meraki system using the API and Ansible to help you automate that. That was a much better way to go. It took a deployment that would have took hours down to maybe a few minutes.
Very good.
And that'd be my simple gripe on it.
Well, Ryan, thanks for the insights. And so, folks, this is just an example. And as Ryan said, we can go on for a long time talking about particular use cases. But again, these are examples how we've actually helped customers with network programmability capabilities that we have on board here. And again, you can use them yourself. If you decide that this is something you want to get into, where should you get started? How should you get started? I'm a believer in the crawl, walk, run theory. So this slide is somewhat of a reference slide. The idea is, well, crawl. Let's start easy. Run those APIs from those API documentation pages like I showed on the Meraki page. Use tools like Postman. In this crawl stage, there's no coding. So that's a good way to get your feet wet with the APIs. You want to dive further into it, let's move to the walk stage. And this is where you might, I would suggest you, if you're particularly in a Cisco environment, get involved with Cisco Devnet. Or if you're your networking environment is one from another vendor, look at their equivalent of a Cisco Devnet. Set up your own development environment on your laptop. Pull down and install these various tools. That is the heaviest lift of doing this, is setting up that dev environment. The nice thing about it is once it's set up, it's there and it's free. Start playing with the Python interactive shell. Start looking at SDKs. In terms of REST APIs, look at the curl tool. That's a nice tool to play with REST APIs. And then start doing some beginner coding. There are lots of YouTube videos and training courses that really cost little if nothing on Python scripting. Also, I'd encourage you to learn some Linux maybe. You don't have to be a Linux guru, because I am not, but it's helpful to have a few of the basic commands down. And then you want to move to the run stage. That's where you get involved with more advanced Python scripts, and you would look and start heavily using config management tools such as Ansible or Puppet or Shell. And then lastly, at a full trot, you'd want to use or get into your CI/CD journey. And CI stands for continuous integration, continuous delivery, or continuous development. That's the concept that you're using a variety of network programmability or network automation tools to make changes to your networking environment, to source those changes, so those configs in a single source of truth environment like a GitHub, where you're implementing them after you automate the testing, and then after the testing, you move them into production, and the circle continues as you continue to modify and grow your network. That's the idea of CI/CD, and that's ultimately where you'd like to get with network programmability. Now, one great way to get started, in my opinion, particularly if you're in a Cisco environment, is take Hank Preston's Network Programmability Basics course. Just click on that link right there, and it's a great course. It's a good way to get started. Even if you're not in a Cisco environment, most of the information, 90+% of the information you're going to learn is going to be applicable, because RESTconf and REST and Netconf and all those various tools, they are vendor agnostic. Okay, they work across all platforms. But this is a great course to get started. So to wrap up, here are some nice resources. And I can send this slide deck to you if you would like. So just send me an email if you would like the slide deck. I won't just unilaterally send it out. But here's some nice resources. YouTube is always your friend. There is a plethora of tools out there to help you learn and get started with network programmability. And lastly, again, if you're in a Cisco environment, maybe sign up for Devnet Create. I think it's going to be virtual again this year due to COVID, but there are the dates. It doesn't cost you anything, by the way, to sign up for an account on the Cisco Devnet platform. That doesn't cost you anything, but you do have to get an ID. So I will leave you with this, with the prime directive to go forth and automate. And would love to hear your feedback on what you've done in the network automation, network programmability sphere. If you have any questions, feel free to reach out to us. We'd also like to know what do you think about this session, and also any other sessions that you'd like us to talk about or topics. So having said that, let me ask one final time, are there any questions out there? Haven't been able to check the chat window. So does anybody have any questions they'd like to shout out? Okay, I guess we've done a good job of explaining things. So I hope you have a great rest of your day, and we will see you on the next Tech Talk. Thank you, folks. Have a good evening. Good day.
Thanks, Pat. That was very informative.